parallel sides. One pair of parallel sides. On your family tree, I need you to label the parts of a trapezoid. The sides that are parallel, and these arrows mean parallel. The sides that are parallel, we call those the bases. So write base and base. Those are the bases. Even though one's on the bottom and one's on the top, they are the bases. The sides that are not parallel are called the legs. So we've got two bases and two legs. The angles that surround the base are called the base angles. So like angle 1 and angle 1, those are a pair of base angles. Angle 2 and angle 2, those are a pair of base angles. So that way, when we name things, now we can refer to them when we're talking about the properties, now that they have names. So property 1, if you haven't written it down yet, property 1 of a trapezoid, one pair of parallel sides. That is numero uno. Property 1 for a trapezoid. One pair parallel sides. Do you need one? Do you have a tree? We need these properties. They're so important. Okay, well, angles, that's a good hypothesis. Angles sum to 360. That's not just true for a trapezoid. That's true for a, what's the very top of your family tree? That's true for all quads, whether they're a special quad or not. So that's not special to a trapezoid. They do sum to 360, though. That's very good. Which ones are supplementary? Good, Ashley. Which ones? Are these two supplementary, 150 and 100? No. So which ones are supplementary? 30 and 150. Oh. What should we call those? Those aren't the base angles. Yeah, let's call them the leg angles. Good idea. If that's a leg and that's a leg, do you agree with me that we could call the angles that surround the legs the leg angles? Is that okay with you? Because the problem is, if we don't call them the leg angles, look at what we would need to say. Look. Oh, wait. Are you going to? Would you really like to write this? Don't write this. Two pairs of consecutive angles are supplementary. Would that mean anything to you when you start solving things? How about instead, I recommend you say the leg angles are supplementary. So that's property 2. The leg angles are supplementary. When I say leg angle, I mean the angles that surround the legs. Not the base angles, but the leg angles. I just made that up. Leg angles is not an official term. You won't find it in a textbook. So I'm just warning you, I just made that up, and Kindle help me. Leg angles is what we're going to call them so that we don't have to write all that jargon. Okay.
Jargon's a word.
Jargon is a word, yes. Okay. This is not a property. This is not a property. I'm just reminding you of this word, and we learned it in an earlier unit. When you find the midpoint of a side, and you find the midpoint of a side, and you connect them, what did we call it in the past? A mid-segment. So I'm just reminding you, you're not writing this down anywhere. This is not a property. I'm reminding you that a mid-segment is when you connect a midpoint to a midpoint. Now there's going to be a property about the mid-segment. Oh, and by the way, it is parallel to the bases, if you were wondering. All three are parallel, so that's cool. Okay, here's the last, number 3, property of a trapezoid. The mid-segment is the average of the bases. You can write the words, or you can write the equation. You can write what's in gray or purple, whichever one you like better, the words or the equation. So in a trapezoid, if you draw the mid-segment, it is the average of the bases. You add them up and divide by 2. It's right smack in the middle. His length is perfectly in the middle of the other 2 lengths. Add them up and divide by 2. That's property number 3 for a trapezoid. So if this is 5 and this is 9, how much is the mid-segment? 5 plus 9, 14 divided by 2. Very good. That's all there is to it. How far apart are 5 and 7? How far apart? 2 apart. So you jump from here to here, you jump 2. So how far do you jump from 7 to 9? You have 2. So 7 is right smack in the middle of 5 and 9. That's how a mid-segment works. That's easy. We like that. Okay. Let's solve some examples. So now you're on your sheet with the examples on it, with the pictures. Very nice. Find angle B and find angle D. Actually, what I want you to do first is label your legs. So when you see a leg, the sides that are not parallel, I want you to put the word leg. I want you to put the word leg. The leg angles are supplementary. Not the base angles, but the leg angles are supplementary. That's how you're going to solve this one. Can you solve this one in your picture? That's a leg and a leg. And we just learned that the leg angles are supplementary. So everyone should be subtracting something from 180. Should be doing some subtraction. Catherine, what's the measure of angle D? You just got it. 77. Very good. This angle is 77. 180 minus 103. The leg angles are supplementary. Ashley, what's the measure of angle B? Thank you. 113. And then you could always check and make sure you did it correctly. If you add up all 4 of these, like we talked about earlier, 1, 2, 3, 4, what should it equal? 360. You can always check your answer. Add them all 4 up and make sure it equals 360 to make sure your shape actually makes sense. All right, example 2. These are easy. Find the length of the midsegment. Go ahead and find it. I would find y first, because we already talked about how to find y. You add them up and divide by 2. You add them up and divide by 2, and then I'll talk about how to find x in a second. I'm just going to take this until later class, because you can't find x and y yet. I just took Dimitri's too, because y'all are, it's just too tempting. Dimitri, what'd you get for y?
I didn't do it.
Okay, get your calculator out. Dimitri, head up. Come on. 2.5 plus... Kendall, what'd you get for y? 5.5. Okay, good. 11 divided by 2. 5.5. 2.5 plus 8.5 is 11. Divided by 2. 5.5. Okay, this one on top, here's what you could do, but I don't recommend it. You could say, okay, I add my bases and divide by 2, and it gets me 13. And then you have to solve for x. Ugh, that doesn't look like fun. So instead, yep, you can play leapfrog. How far do you leap from 13 to 17? 4. So you just leap 4 again. 13 minus 4. 9. Very good. So when you're looking for a base, not the mid-segment, you can play leapfrog. When you're looking for the mid-segment, that's when you add them up and divide by 2. Okay. Moving on. Doing great. Solve this one. Go. Add your bases and divide by 2. And that will equal your mid-segment. You have a formula. You should have written this on your family tree. Mid-segment is base 1 plus base 2 divided by 2. You should be writing something down on your page. Write the equation down on your page. Don't go straight to your calculator.
Where's this at?
Where's what at? Oh, I'm sorry, I changed. Oh, I forgot to say. Can you change these numbers because I made it prettier? You're going to want to do these instead. Can you just scratch yours out and change it to those, please? Sorry about that. The ones on there before came out to a really weird answer. So here's the equation you're using. Base 1 plus base 2 divided by 2 equals the midsegment. Lewis M., can you set up an equation for me to write? 11. Wait, let's add base 1 plus base 2. 11 plus 25 divided by 2 divided by 2 equals, what's my mid-segment? What's my mid-segment? Okay. This is step 1, guys. If you didn't write this down, you need to write this down. You add your bases and divide by 2, and that's your mid-segment. Let's make the left side pretty. Megan, what is 11 plus 25 divided by 2? 11 plus 25 divided by 2.
Oh.
Yeah. 18 equals x plus 5. How did you get 18? 11
I knew that already.
plus 25 divided by 2. You have to press enter because you did 11 plus 25 halves.
Oh.
You got to either use parentheses or you got to press enter. You got to either put parentheses here or you got to do 11 plus 25 enter divided by 2 enter. Okay, last step of this problem. Julius, what do? How do we solve for x? What's the opposite of plus 5? Minus 5, come on. X equals 18 minus 5? 13. Woo! X equals 13. We already know AB. I gave it to you. It's 11. And then plug 13 in. EF. 13 plus 5. 18. We're back to 18 again. Yeah. Okay, let's keep moving. Ooh, next word. Isosceles trapezoid. I bet you know exactly what an isosceles trapezoid is. It's a trapezoid with congruent legs. So the trapezoid now has 2 legs and they're the same length. So they have tick marks on them. That's not, let me show you. Here's property 1. So property 1 of an isosceles trapezoid is that the legs are congruent. So you're on your family tree and you're writing down legs are congruent. Family tree, trapezoid, isosceles trapezoid. Legs are congruent. What is my second picture showing?
Opposite.
Not opposite.
Base angles.
Base angles are congruent. Very good. Just like in an isosceles triangle, if the legs are congruent, the base angles are congruent. That's true with an isosceles trapezoid as well. If the legs are congruent, then the base angles are congruent. Congruent means they're the exact same. So I bet if I give you one angle, you could know all the angles. If I said that this is 70 degrees, I bet you could find all the angles. If that's 70, class, everybody, what's this one? 70. Ooh, if that's 70, what's this one? Good, 180 minus 70, very good. 110, 110. So that's how the angles in an isosceles trapezoid work. Guys, I want you to realize real quick, an isosceles trapezoid is just like an isosceles triangle with its head cut off. If you take an isosceles triangle and you cut the top off, you get an isosceles trapezoid. So it's going to work just like an isosceles triangle with the top cut off. Okay. Next property. What am I showing there? Put it into words. Put my picture into words. The diagonals, the dotted lines are called diagonals. AC is a diagonal. BD is a diagonal. The diagonals are congruent. Last property of an isosceles trapezoid. Diagonals are congruent. We're almost done filling out this family tree. So it just means the diagonals are the exact same length. No mystery there. Okay. Let's try some. I'm going to let you do your practice. Oh, you already know how to do this. I give you one angle, you know all the angles. Go. Show me what you know. Show off. I give you 42, you can find all of them. Brett, what's angle C?
42.
Awesome. Nasia, what's angle B?
138.
Awesome. Melanie, what's angle A? What? Yep, 138. Woo, that's easy. Right? Y'all are dead today. Oh my gosh. Smile or something. I don't know. Okay, moving on. Angle D and angle C. Ava, are those supplementary or are they congruent?
Wait, what?
Okay, so we're on example 5, and I'm wondering if this angle and this angle, do I set them equal or do I add them to equal 180? Set them equal, very good, because we're in an isosceles trapezoid and those are the base angles. So we will set those equal. Solve for x, solve. Louis C, I'm going to call your names to solve for x. Oh, never mind, immediately. Put your calculator away. Torrance not here. Matt, do you have x yet? 6, thank you. Oh, there's not even a spot for x. 6, so we plug it in. What's 6 plus 7? That's a small angle, guys. You realize that? 13. When you know one angle, you know all angles. 13, 13. What's the supplement of 13? 167. And then 8 times 6. We've now moved from angles to sides. 8 times 6. 48. Oh, I thought you were saying 37. 48, and those legs, yep, they're congruent. So if one leg is 48, the other leg is 48.